Now we're going to look at what's the rule regarding the multiplication property of exponents. So we have 3 examples, and through these 3 examples, hopefully the rule becomes pretty obvious and apparent. The first example says, what's 6 to the 4th times 6 to the 5th? So 6 to the 4th means 6 times 6 times 6 times 6. And then 6 to the 5th means 6 times 6 times 6 times 6 times 6. So on the whole, 6 to the 4th times 6 to the 5th equals 6 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 9 sixes. Now let's take a look at e to the 5th times e. And in this case, that we have to know that there's an invisible 1 right there, that we know it's there, but we don't write it. E to the 5th means e times e times e times e times e. And we're asked to then multiply it by e. And that leaves us with e as our base, and the exponent would be 1, 2, 3, 4, 5, 6. So our final answer would be e to the 6th. Now, for this last one, f to the 6th times f to the 7th times f to the 125th. I'm going to go ahead and tell you that the answer would be f to the 138th. Unless any of you are really dying to write out all 138 f's, I figured I would save you that. Hopefully you have noticed that there's a pattern. Notice with 4, when we had 6 to the 4th, 6 to the 5th, and we multiplied them, we got 6 to the 9th. Or e to the 5th times e to the 1st, you get e to the 6th. So if we have f to the 6th and f to the 7th and f to the 125th, we got f to the 138th. The hope is that by this point you have noticed that to multiply numbers or variables that are raised to a power, add the exponents or numbers, add the exponents of the numbers or variables with the same base. The important thing to note is they have to have the same base. If the base is different, you can't put them together. So let's take a look at a few examples. 3 to the 3rd, 3 times 3 to the 3rd. So in this case, we end up with 3 to the 4th, and you'll notice in the directions we are asked to simplify it completely, meaning 3 to the 4th is 81. And we got 3 to the 4th because 1 plus 3 equals 4. We added the exponents. Taking a look at the second one, m to the 5th times m to the 7th times m to the 81st. Hopefully you've noticed that it's going to be 5 plus 7 plus 87, meaning we get m to the 99th power. For a to the 5th times a times b squared times a to the 11th. We can note that 3 of them have the same base. So we add the 5 plus the 1 plus the 11, and that gives us a to the 17th. However, b squared can't be combined with them because it's a different base. So just plain and simple, it's just b squared. So the final answer would be a to the 17th b squared. Number 4, x squared, x to the 3rd, x squared, y to the 4th, x to the 3rd, y. We have our x's, x squared, x to the 3rd, meaning we have x to the 5th, and our y's, y to the 4th and y, mean it's going to be y to the 5th, so it's x to the 5th, y to the 5th. For 3 squared times 3 times 2 to the 3rd, we should note that we have 3 squared times 3, which is 3 to the 3rd, and 2 to the 3rd would simply stay as 2 to the 3rd. We have 3 to the 3rd, which is 27, times 2 to the 3rd, which is 8, and that's going to equal 216. And then for the last one, we have c to the 4th, d to the 7th, c to the 17th. For c to the 4th times c to the 17th, that's going to be c to the 21st, and then d to the 7th just gets added on. Now, if you want to put a multiplication sign in between any of the variables, that's fine, but it's not required, and you're not going to see any math teacher write it that way. We just write them knowing that when they're beside each other, they mean multiplication instead of writing them with the symbol. but you will not be marked wrong if you choose to put the symbol, the multiplication symbol there. Now, what do you do when there are coefficients? You've got to remember that coefficients are going to be the numbers, the constants that are multiplied by the variables. The answer in this case is going to be multiply them. So this one would be thought of as 6 times a to the third times 3 times a times 2 times a to the fifth. 6 times 3 times 2 is 36. And a to the third times a to the fifth is a to the ninth. Now, in looking at these examples, we have 6y squared times 3y to the third times 2y to the fourth. So your coefficients are going to be 6 times 3 times 2, which, as we saw in the earlier one, is 36. Y squared times y to the third times y to the fourth. 2 plus 3 plus 4 is 9. So we get, in this case, 36y to the ninth. All I did was change the variable and the exponents, but it still works out the same as the first one. And looking at number 2, we have 2y to the third times 7x squared times 2y to the fourth. So 2 times 7 times 2 is 28. Y to the 3 plus 2 plus 4, 3 plus 4, which is 7. And then there's nothing to go with the x. Now, I will say that typically math teachers like to write them with the variables in alphabetical order, but if you want to write it as y to the 7th x squared, that's fine. You're not going to get marked off as long as it's the correct addition or multiplication. Now, in taking a look at the last one, we have 5m times 2p to the 4th times 3m to the 8th. So we multiply 5 times 2 times 3, and that's going to give us 30. And then we have m to the 1 plus 8, which is 9, and then p to the 4th. Again, preferably the answer is written with having the variables in alphabetical order, but if you were to write it with the variables in reverse order, that's fine. You're not going to get points taken off for that. And that pretty much sums up the multiplication property of exponents and the rules you have to use.